This video is about electronic configuration, also called electronic structure. There's a rule that we have to first be aware of before we start doing this, and this is referred to as the 288 rule. And what this means is that in the first shell of any atom, there can be a maximum of only 2 electrons. In the second shell, there can only be a maximum of 8 electrons, and in our third shell, a maximum of 8 again. There is a fourth shell, but you will never get examples in GCSE where you actually will have to complete the fourth shell. You will get examples where you will actually put electrons in there, but because you're not going to complete them, you don't need to worry about how much that goes into the fourth shell. Okay, so let's apply this to an actual element. I'm going to start off by looking at sodium. Now, sodium has an atomic number of 11, which means that it has 11 electrons. Now, something to bear in mind is that when you're putting electrons in the shells, you have to make sure you complete the shells in order. So that means complete shell 1 first before you move on to shell 2, and so on and so on. So I've got 11 electrons to play with. 2 have to go into the first shell, and that completes that first shell. And then I have to put 8 in the second shell. And so now I've got 1 more electron left, and that will have to go into the third or the last shell. Now, you might already know this, but if you look at the last shell, you can see that sodium has 1 electron in there, and that's the reason why it's in group 1. So let's have a look at another example now. So this element is magnesium. You can pause the video and try to complete this yourself. So magnesium has an atomic number of 12, which means that it has 12 electrons. So once again, 2 electrons have to go into the first shell. I've got 10 remaining, so I can only put 8 now in the second shell. Two more electrons remaining, and they go in that third shell. And that's pretty much it. I want you to now try the same thing with calcium. Now, calcium has 20 electrons, so you're going to need a fourth shell. Like I said in the beginning of the video, you don't need to worry about the maximum number of electrons that can go in the fourth shell, because you'll never get any examples in GCSE where you'll be asked to complete that shell. So you can pause the video and have a go at this. So you're going to have 2 electrons in the first shell, 8 in the second shell, 8 in the third shell as well, and then 2 in the last shell. And that's pretty much it. So the last thing I wanted to go through was how to write electronic configuration in the numerical form. So let's start off with our first element that we looked at, which is sodium. We said that there are two electrons in the first shell, so we put a comma, and then the second shell contained 8, and then put a comma, and then the third shell had 1 electron. So that can be also written as 281. Moving on to magnesium. Magnesium has 2 electrons in the first shell, 8 in the second, and 2 in the third shell, and that's written as 282. And our final one that we looked at was calcium. So calcium has 2 in the first shell, 8 in the second, 8 in the second, and 2 in the last or the fourth shell. In this last part of the video, we're going to be looking at drawing electronic configurations for ions. So I want to draw the electronic configuration for a magnesium 2+ ion. This means that it's lost 2 electrons. So instead of having the 12 electrons, as shown over here, we actually have 10 electrons. So we'll do the same thing we did earlier on. So 2 in the first shell, got 8 left to place. 8 will have to go in the second shell. and that is 10 electrons. Now, when you have an ion, it's good practice to put it in square brackets like this, and then you put the charge on the top right hand side outside the bracket. So in this case it's 2 plus, so I put a 2 here and then plus. So always the number first and then the charge. So let's look at the last example. This last example involves a negatively charged chlorine, which is also referred to as a chloride ion. Now, it's got a single negative charge, which means that it's gained 1 electron. I'm going to give you the symbol for chlorine just to help you with this. So chlorine has an atomic number of 17, which means it has 17 electrons, which is the uncharged chlorine. You can pause the video and have a go at this. So once again, we'll do the same thing we did last time. This time we have 18 electrons because it's gained 1 more electron. 2 go in the first shell, 8 go in the second shell, and then 8 go in the third shell, which adds up to 18 electrons. Now once again, when you have an ion, you have to make sure you put the whole atom in square brackets and then put the charge on the top right hand side corner on the outside of the box, or the bracket, sorry, and there's a minus charge there.